Hello everyone, Rezi here and welcome to my channel. We're going to continue with our Unreal Engine 5 for Beginner series. This week we're going to start with basics of lighting in Unreal Engine. We start by making our very own Cornell Box and talk about errors you may run into when you export an FBX into your Unreal Engine scene. We then talk about Lumen, why we use Lumen and how to use it. Then we start exploring light types inside Unreal Engine 5 and all the key attributes you need to know about so you don't spend all the time scrolling through a long list of properties for every single light. Only then we switch to a much bigger scene and explore some complementary tools such as volume clouds and sky atmosphere. Remember, this is just an introductory video and my intention is to add a lot more to this by using these tools during production from now on and hopefully in the future videos. So understanding the basics of lighting in this video is actually quite important. As usual, I've added timestamps so you can always go back and repeat a specific section. With this out of the way, let's get started. Now let's spend only a few minutes inside Autodesk Maya and create our own Cornell Box. And in case if you're wondering what a Cornell Box is, it's a commonly used 3D test model. It's basically a box with a skylight, and that allows you to test your textures, test your materials and shaders, test your lights, and of course test your renders. I'm going to put a link in the description. We are going to kind of use that, and the reason that I'm not actually starting from the ready to go one inside Unreal is because I'm going to use this tiny chapter as an excuse to show you the errors that you may run into even when you create a box. So I'm just going to go into new. By the way, once this is done, I will happily post this cube on my Patreon page. I'm going to delete one of the faces. Now you can see that the inside is black and the outside is gray, meaning that the direction of the normals are pointing outward. It should be the other way around. However, what you can do is to give this box a thickness, and that is going to fix the issue. I'm probably going to hide the grid here. Now I'm going to really quickly go to multi-cut tool. I don't want this chapter to be too long. It's not about modeling inside Autodesk Maya. I'm going to use multi-cut tool to create a cross, and then I'm going to select that vertex in the middle, shift right click, and I'm going to chamfer it. I'm going to select the face, scale it up a little and press delete. Now we're ready to extrude. Shift right click and I'm going to extrude and extrude along Z-axis, and you can see that fixes the normal situation. It doesn't matter how thick or thin this model is. Now this looks good. You can even go in there into edges and start sort of tweaking and adding bevels, so on and so forth. But to be honest with you, for a simple scenario like this, it's a bit of an overkill. I'm going to go into these four faces and faces on the ceiling and on the side and the back, and give this a black Lambert. So assign new material, Lambert, and I'm going to make this Lambert black, and I'm going to call this black because my intention is to bring in shaders into Unreal as well. Would be a good idea to delete by type history, makes it a lot easier. And now I'm going to go and select all of these guys, and I believe I did give this a tiny bevel, so I'm going to select all of them, and I'm going to select this one and this one, shift right click, new, and I'm going to go to Lambert. This is going to be a white Lambert. The color for the white is usually 80% white, so 0.8 for white. I don't need any specularity or any highlights. That's why I'm using Lambert as opposed to Blend or Fong or any other type of material. Now, as we talked about this, the left wall is going to be red. So right click, and I'm just going to bring another Lambert, call this red, and I'm going to use one of these presets in the color chip, make it red, and the other wall is going to be green, another Lambert, green, and make this one of the presets green, and we are ready to go. What I usually do, especially with a cubic model like this, I always go to mesh display and I harden the edges. At the end of the day, once everything is done, what I can do is to go into delete by type and history, and we are ready to export our model. Now, a bit of a disclaimer: when you export this model, you will be getting some warnings, and I intentionally not going to fix any of these issues right now because we would like to kind of use that as an opportunity to learn something new. So with that said, I'm just going to select that. I'm going to go to File with the object selected, Export, and Export Selection into, and I'm going to go all the way into FBX Export and go Export Selection. And one thing I try to fix from the get-go is Advanced Options, Axis Conversion, Up Axis in Unreal is Z. So I don't need to convert this scene when I do that. So I'm going to go to Desktop, and I'm going to call this Cornell. Actually, I'm going to go to Unreal folder that I have, and I'm going to create a new folder. I'm going to call this 04_lighting, and under that I'm going to create another one, FBX, and put Cornell Box in there. Export Selection. Now let's go to Unreal and see how we can import this model. I'm going to double click on the Unreal Engine shortcut, and we are going to use Games, a blank scene, and the path is going to be this folder that we just created. If it's not there, you can always right click and create your folder, but we already have it. So let's select the folder, and I'm going to call this lesson 4_lighting. We want blueprint to stay there. We want starter content to be enabled. We don't use it, but let's have it there, and ray tracing off, and let's create. Here we are inside Unreal Engine 5. And now, because I enabled starter content, I'm getting this, but that's no problem at all. You can always go in there and start with a brand new level. Before I do that, I would like to create my own folder structure. So right click, create a new folder, 04, and well, actually I call it lesson 04_lighting. And again, these are the things that we keep repeating every single session. Of course, you all know this by now. Call this one levels, and I'm going to have another one, new folder, and call this props, so we can bring our Cornell in there. I'm just going to create another one and call this textures. You will know why. We do have some textures that I would like to bring, and that should do the trick. I'm going to go and create a new level. I want that level to be basic, and I'm going to basically open the scene. We've got a static mesh. We really don't need it. I'm going to hide it for now, but chances are that I am going to actually delete it. I'm going to go to prop, and let's bring our Cornell Box inside FBX and Cornell Box and open. Now, because I changed the up axis to Z, I don't need to convert the scene, and everything else looks okay. But if I press import all, I'm getting 3 errors, or 3 warnings rather. Now, it is important to understand why we're getting them and how to fix them, because yes, we are bringing a simple box, but sometimes you bring some delicate objects that you really need, and you kind of need to know how to address these warnings and how to fix these issues. So The first one is about smoothing groups that needs to be enabled when you export anything from Maya into Unreal Engine. Now, the other two talks about tangents and binormals. Now, let me show you what these errors are and how to fix them. I'm going to select all of these guys and press delete on it because I would like to re-import this Cornell box, and let's switch to Maya. All right, here I am inside this scene. Now, what you need to do, and the two errors that we're getting are mainly coming from UVs. You can see we have overlapping UVs, and this can cause problem. There's a very simple solution, at least in this one, and that is for me to select the model. Actually, I need to know what I'm doing here. So select the model, go to UV, and you can do a planar, go one by one and do a pretty neat job. But because we do not have any textures, I'm just going to go with a simple good old automatic. So 6 probably is actually a good number. With the model selected, I'm just going to go project and enable the checkerboard, making sure that I'm actually getting evenly distributed quads all across. Yep, that's going to fix that. Now this is going to take care of the tangents and binormal errors. The first error, smoothing group, that I was getting is when you export your model. So I'm just going to go export and go to FBX. And when you would like to export, it's under geometry. You need to make sure that smoothing groups is turned on. Now with all these warnings addressed, you can easily overwrite this model. Now let's go ahead, jump back to Unreal Engine and see if we can bring our model into the scene with no error this time. Here I am inside Unreal Engine. I'm going to go to import Cornell, open. I don't need to convert scene, and import, and voila, it just worked. Of course it's tiny, so I'm just going to select the scale, click on this padlock and probably increase that 10 times, maybe. Move it up, see if that works. It definitely is working. I'm going to press E to rotate it ever so slightly, press F on it. Having a quick look just to make sure that everything is kind of working fine. Maybe rotate it in 90 degrees. Yep, we are ready to go. At any point of time, if you would like to edit any of these materials, you can just double click on them, and we already talked about materials, so you kind of need to know how they work, so on and so forth. So for example, if you're getting a little bit of reflectivity in there, that's really easy. Number 1 on the keyboard, left click to create a constant, and you apply it to your roughness value and make this roughness set to 1, and you can press apply, and that is going to fix that for you. So hopefully with the knowledge that you have, you should be able to go back and tweak a few things if need be. You can do the same thing in here, and once everything is set up, we are ready to start with our lighting. So let's go to the next chapter and explore Lumen. Now our scene is ready, let's talk about Lumen. I've gone ahead from shapes menu, I've brought a sphere and a cylinder and used the starter content material tab just to add some materials to our primitive, something really simple, so we have basically something to start with. What is Lumen? So until Unreal Engine 5, for all the supplemental indirect lighting illumination, Unreal Engine had to rely on screen space global illumination, SSGI, to pre-compute all the lighting bounces. That was a very expensive and limited process. Now, thanks to Lumen, everything is real time. So we're not going to rely on costly calculations. Everything is almost fully dynamic. Instance and global illumination and reflection system can be calculated real time. That's a massive improvement in performance and in accuracy when it comes to GI, global illumination, and how Unreal Engine calculates light bounces. How to enable Lumen, how to make sure that Lumen is enabled. That's actually enabled by default. So you go to Edit and you go to Project Settings. You look for rendering, or you can just type in Lumen and you can see, with one M, and you can see that global illumination is set to Lumen and reflection is set to Lumen. At any point of time, you can go in here and change that to SSGI or to a standalone ray trace plugin, which is used for offline rendering, and it's very expensive. Now, with that out of the way, let's go ahead and hide all of our lighting setups here and start from scratch, start from the very first lights in the scene and explore all the attributes. So I'm just going to hide that lighting and everything goes black. We go to Add Light, and let's start with a simple point light. You can either click on it or you can left mouse drag and drop it into the scene. So instantly you can see that we're dealing with a fall off. So if I just Alt right mouse button, you can see that fall off is our attenuation, how much of this world this light is affecting. And this fall off or this attenuation attribute is something that is common amongst all the light types. We can see the icon here. We can reposition it, scale it, rotate it. But because this light works much like a light bulb and emit light in all directions, rotating it is not going to much of a difference. Now, another attribute that all of a sudden we see appears is the mobility. We've got static, we've got stationary, and we've got movable. Although it's a little bit difficult to explain how they work because we're not in the gameplay, and the only time you see the difference in these three is when you play game. Just to put it very simply, static lights, as you can see, as soon as I switch to static, they need to be baked. They're the least expensive type of light. They give you the best performance, basically, but they're very much limited. Because everything will be baked, they cannot be changed or they cannot be moved in any way at runtime. And if you do that, your light will break. Another problem is because you're baking the light, then the character, the object in the gameplay is not going to react to it, or the other way around. That light is not going to cast shadow on a moving object during gameplay. So yes, the performance is fantastic, but they're very, very limiting. The other type is stationary, where it's semi-dynamic. No, it doesn't need to be baked every single time, but as the name suggests, they wish to stay or remain stationary. So you cannot move them during gameplay, but you have a slight degree of flexibility or freedom over their brightness, which is the intensity, and the color temperature. So they can be changed, but they cannot be moved. So it really comes down to why you're using this light, what role your light is playing. Is it in the far background? Is it something that the character is carrying? Is it going to interact with the character? Now, the most expensive one is movable, but at the same time, it's the most flexible type, which is a fully dynamic light, which is capable of changing all of its properties during runtime. So if you know that your light is going to interact with an environment, your light is going to interact with a character, it's going to bounce and receive a color from the environment and from its shadow as well, and everything is going to be dynamic and interactive, then you need to make sure that your light is set to movable. Now, with this out of the way, let's talk about some of these attributes. I'm just going to scroll down and get straight into attenuation radius right under light rollout. Now, if you pay attention to this, you can see that changes how big of an area this light is going to have an impact on. I can just bring this light a little bit closer so you can see it will have an impact on our objects in the scene. Of course, you can change the intensity, bring the intensity low or up, and the unit CD is called a candela or CD, which is a light unit. You may want to bring this down a little bit just to lower the intensity, or you want to intensify the effect. You can see how interactive this looks. I can just zoom in a little bit so you guys kind of get to see better. I can bring the intensity down or bring it up. You can see how interactive and responsive this light is. The other one is interactive lighting intensity, and again, that's where Lumen really shines, because if I increase that, you can see the number of light rays bouncing around and illuminating the scene instantly. So you can see no light bounce, light bounces, no light bounce, and indirect illumination kicks in and gives the scene more illumination, and that's because of the ray bounces around the scene. So that is very, very cool. Borderline incredible that we see this all real time and it's physically accurate. Of course, we can make a decision objects to cast shadows or not, if this light is going to affect our world or not, and source radius actually looks at, if I select this sphere and zoom in, and if I look at the edges or the core shadow or the shadows that it's casting on the ground, you can see that we can actually blur them like so using this attribute. But make sure not to go overboard with this, because as soon as this sphere goes bigger than our attenuation, it creates artifact. It will have an impact on our shadow, and you can see it's now messing up with our shadow. So a little bit of source radius is going to be quite helpful to get a much useful result. Now, with that out of the way, before we get into the second type, I would like to bring one node that is going to help us get a much more accurate result, and that is post-processing volume. Now, this allows us to basically define the overall look and feel of your scene through a combined selection of properties and features that affects color and tone mapping and lighting and so much more. So every time I tweak around with or play around with lights, I always have post-process volume in the scene just to make sure that what I'm doing is correct. Now, right now, this post-processing volume only affects what's inside this volume, but there is an option called infinite extend. If I tick that on, any change I make in any of these attributes will have an impact on the entire scene, because I set the extension to infinite. For example, if I go to exposure and say, all right, I want to do exposure manually, then I can go in here and say, all right, I'm just going to set the exposure, and that's the exposure for the entire scene. And of course, that goes hand in hand with the intensity that I have on my light. So you kind of need to be mindful of these two nodes at the same time, or even more lights if you have in the scene at the same time. So what I suggest is every time you start testing lights, make sure your post-process volume is in there, so you can basically keep track of overall look of your scene. That out of the way, let's go to the second light that we would like to introduce. And the second type of light is spotlight. I'm just going to bring in a spotlight, and I'm going to hide my point light. Now, just like point light, which is a omni type of light, you will be getting an attenuation. You will also be getting this cone. The reason that you're getting this cone, because a spotlight emits light from a single point in a cone shape. So it's very similar like a flashlight or a torch, if I may, where you get, if I could showcase the light rollout, you get inner cone and outer cone, where the inner cone gives you full brightness, and as you go from the edge of the inner cone or inner radius to the extent of the outer cone angle, that's where the fall off takes place. So right now the inner cone doesn't exist. I can just extend it or bring it up. Now you can see we've got the inner cone, where inside this inner cone you'll be getting the full brightness, and as you move forward from the inner to outer, that's where the gradient happens. Just like other types of light, including point light, you get static, you get stationary, and you get movable. A very, very useful type of light. I can move it in, I can change the inner cone, and you can see now it's kind of limiting my exposure, so it's only brightening certain areas. Within the same rollout, I can go and make use of all of these attributes that we had. For example, intensity, candela, set to 8 is one of them. And as you can see, as I increase that, I'm getting more bounce lights coming in, but we have indirect lighting intensity that kind of helps us to make the scene even brighter. You may say, Reza, can we just move this up? Well, as soon as you move this up, as if like there is light coming through this skylight, all of a sudden everything goes dark, and it's because, yes, you guessed it, because of the limited attenuation. So we had attenuation in point light, we have attenuation radius in spotlight. All you need to do is just to let this spotlight that, all right, cover more areas, further areas. So increase this attenuation radius from 1000, let's say, to 1500, and all of a sudden that light will reach farther distance in space. Everything else stays the same. You can see that's where it the resolution kind of drops a little. You can select your post-processing, type in Lumen, and within here you can see that the global illumination set to Lumen, and you can look at the final gather quality and increase that to something like 2 to get a much better result. So pretty much everything else in Spotlight is what we expect to see. I'm gonna get rid of this filter here. We do have shadows. We can soften the shadow of the object. So if I kind of zoom in, select the light and zoom in, you can see that I can go in here and play around with source radius, and all of a sudden we get a much softer details, shadow details. I can make use of temperature, so I can go in here and just say I would like to use temperature instead, where the cooler color will be achieved through higher value, and if you want to get a warmer color, you just reduce the temperature and everything gets slightly warmer. Now, one use of this type of light is where you have IES. IES is a type of a data file, and that defines how your light looks like. You can actually, I can cancel this, you can actually download IES data files online and attach that to your light to get a slightly different shape. Let me show you how. I'm just going to get rid of this use temperature, and I'm going to bring my light inside this Cornell box. So I'm just going to bring that in. So you can see the fall off that I have right now looks like this. It's more of a cone shape, and the base of it is more like a circle. I can bring down the intensity to maybe something like 120. Even the default should work. A little bit more indirect illumination. By the way, these numbers can be overridden if you want. Now I'm just going to attach a IES to this light to show you how the look of the light can change. For this particular example, I'm going to download my IES from this website. It's called IES Library. You just look at different profiles, whatever you would like to pick, just to give it a more realistic look. You scroll down and you just click on this download IES, and you can download the light profile that you have. It's a data file, so you need to bring it into Unreal Engine. So what I'm going to do, I'm going to go to listen for lighting. I'm going to go to textures, and I'm going to drag and drop my IES in there. My light profile gets added. Now, where to add it on this light? You need to scroll all the way down, and you've got light profile, IES texture. All I need to do is drag and drop it, and done. Now, if I click away, you're not going to see much of a difference because you still need to tweak the inner and outer cones or radius for your light to be able to see things better. So I go to my spotlight, and I'm just going to start adjusting some of these inner and outer cone radiuses. And of course, I'm going to just tweak some of these lights a little bit. So I'm just going to frame this really quick, move it against the wall so you kind of get to see the profile like so. Now if I click away, you kind of see what sort of profile this gives us. If I click on the actual profile of the light, you can see it's actually quite similar. I can actually zoom in on this spotlight and just show you that even inside this light, you get a slightly different profile for the physical light, which results in a much more interesting fall off for your light. So that's another use that I try to kind of benefit from when I work with spotlights. Just keep that in mind that IES can be applied into any light. We have light profile in point light as well. I can just have a look here. You can see you got that there, but usually in real life you do have light profile IES data file assigned to downlights, and downlights are mainly spotlights. So I thought it would be a nice addition to kind of demonstrate that on this type of light. Now, with that out of the way, let's go and explore the next light type. I'm going to hide this and go into light, and I'm going to bring in a rectangle light. Now, rectangle lights are an interesting ones. They emit light into the scene from a rectangle plane. So I can go ahead and kind of press E on the keyboard to rotate it, and you can see it's pretty much a rectangle. I can scroll up just to be a little bit accurate. I can rotate it 90 degrees. I can select the light and move it up. And even I can press F to sort of zoom on it. And if I look at it really closely, it's a rectangle I'm dealing with. I can even select that and just map it to my skylight that I have. So I can just go in here and play around with source width and source height. I can make this slightly bigger. Can bring this forward. You can see how you can kind of close the barn, make it open or close it, and make sure that you can just bring this down a little to avoid that artifact in the beginning. You can see that you can actually change the length of the barn doors to really get a very, very sort of stylish look. Very kind of different type of looking, very indoorish looking using area light. Good thing about area light is because of that barn door, it looks like the light is projecting on the ground as opposed to naturally shining. And that can be used in many ways. For example, you can project textures on the ground because of the nature of the area light. You can use area light as a type of soft light that we use in photography. So if you feel like a corner is way too dark in your interior scene, best way to add a little bit of illumination is to bring an area light close by, close to the dark area, and just increase the number of bounces through indirect lighting intensity. So I can actually do that, and you can see what an interesting compromise where you have your focus, but at the same time the areas that we do not have the barns, you know, the exposure is not there, they still receive a little bit of bounce. Like just like any other types of lights, we get to have intensity, we get to have attenuation, of course, which is indicated by that blue circle. We get to have effects world, cast shadows, and all the other type of properties that we've had in other types of lights. Another very common use for these lights is to attach gobo to it. So we've got source texture, as I mentioned, where you can just attach an image and receive different very interesting looks like this, where you may not have trees or the actual leaves in the background, but all you need is a map, something like this, a black and white map, just to fake the details that you have on the ground. For example, I have this image, which is super low resolution, but you can see how it fakes the look of the trees. You can easily bring that image into your textures and just assign that to your light. And you can see instantly we're getting a very different look where the light actually projects the image on the walls. So very, very useful, very handy, and that's another reason or another motivation to use rectangular lights as opposed to other types of lights. Again, this option is available on spotlights. You can definitely use these gobos on spotlights. You can use them on point lights, although again, because point lights emit light to all directions, they're omni type of lights, you may not get an ideal result because there is no area of focus. Pretty much 360 degrees around the light is going to be the area of the focus, but best is to use IES and source texture on rectangular lights and spotlights. The rest is pretty much the same. Let's go talk about another type of light. I'm just going to hide this and let's go to the next type. I'm going to go to light and let's bring my favorite probably, and that is directional light. Now directional light is where you see life because they simulate sunlight. I can actually rotate this around, and that's where you kind of, it looks like you're getting a sunlight coming in. Just like any other type of light, you have source angle to soften shadows. You get to change the intensity. I'm just going to lower the intensity ever so slightly, but that's basically where the magic happens. Again, the scale and the position of this light is irrelevant. What is relevant is the angle of the light. So you can go in here and basically press E and start switching things around, and you can see how beautifully and dynamically the light changes. So that's pretty much it. The advantage that we have in directional lights, because 90% of the time you would like to simulate sunlight using directional light, many times where you're using directional light, you actually want to use light shafts with it. So that's one advantage that directional lights have over other types of lights. So if I scroll down, you can see we've got light shaft and we've got light shaft bloom. Unfortunately, right now they're not going to do any work because this type of light, directional light, needs to be associated with the sky and the sky dome in order to work. Now, while I have this light in here, I'm just going to turn this off, and I'm going to introduce another type of light to you. I'm going to go to light, and this time I'm going to bring a skylight. Now, for exterior scenes, skylight is a must. Skylights are extremely powerful. They capture distance part of your level based on the distance that you set, and they apply that to your scene as a light. So let's say if you're in a sunset environment, that sunset casts orange color. This object or this node is going to attract all of these color information and scatter it onto your scene, injects that color flavor into your scene. It's very powerful. If you look at the icon, you can see that this light is actually capturing all the surrounding and emits this to the scene. Just a visual cue to memorize the functionality of this light. The only thing is, this light doesn't do anything by itself. Well, first things first, because we don't have anything in the scene. Even if I bring in this rectangular light, or let's say I'm going to bring the directional light, you can see the sky, the environment is pitch black. So basically what this guy does, it brings black color into the scene. Basically no illumination, no information into the scene. So in order for this light to work, we need to have more nodes in the scene, more information in the scene. I think that's our cue to switch to a much bigger scene where we have objects and vegetations, and that allows us to see things clearly, how the combination of a skylight and a directional light is going to help us to illuminate an outdoor scene. And of course, to do that, we need to add a project to this scene. Now, this will be covered in the next video, but let's prepare for it first. I am going to just hit save in here, so save current level, and I am going to launch Epic Games, go to Marketplace, and in the search bar, type in Modular Neighborhood Pack. Right now, Dokoyo is kind enough to make this product available for free, and I thought it would be a great idea for us to be able to download this amazing pack so we can do our test study on this amazing work. So make sure to check it out. Just search for modular neighborhood pack, add this to your cart. At the moment of the time of the recording, this product is free. So hopefully it will remain like this, so you can basically follow along and do the same. Once you download it, you can add this to any projects. I can just click on it. Right now I'm working on lesson 4, lighting sessions, so I can just add this to my project. Go to Unreal. You can see under content, now I have modular neighborhood pack. Of course, you have access to everything, to the animation, audio, blueprints, so on and so forth. But what I would like to have a look at is all the levels, which you can find under maps. And then you have demo map. You can double click on it and it asks if you want to save objects that we've brought. Of course, they can stay, no problem. And it loads the map. Now let's end this class right here because this video is getting too long, and let's go to the next video, next session, and that allows you to go over these lights that we just talked about and get the hang of them, understand them, and even play around with other attributes because we just targeted all the key ones. And in the next video we are going to bring up this scene and talk about those complementary tools, how to add sky, how to make use of exponential height fog, so on and so forth, which some of them work in conjunction with our direct lights and skylights, and basically put our knowledge into a real practice. Cornell Box, that's great, but having those lights in a real environment is a different story. So let's go to the next video and explore how we can use the knowledge that we have right now to light an exterior scene. Thank you very much for watching this tutorial until the end, and let's pick up where we left off in the next video.